I'm Heidi Luna, and I'll be going over my top 5 queries from chapters 4 and 5 for homework assignment number 3. My first top query is chapter 4, exercise number 3. Exercise number 3 asks me to write a query that returns employees who did not place orders on or after May 1st of 2016. The tables involved are the T-SQL v4 database, employees, and order tables. And this is the desired output you should receive for exercise 3. Okay. Here's the code I wrote for exercise 3. Lines 4 through 9 show the original query I wrote to be tested on the T-SQL v4 database. And after getting the desired output, I modified this code in order to work for the Northwind server. Lines 12 through 19 show the new query for the Northwinds database server. The proposition still holds to return employees who did not place orders on or after May 1st, 2016. The tables in which data will be selected from are human resources and sales.orders. So this is sales.orders and human resources.employee. Line 14 shows the select keyword, which is used to specify the columns we want to retrieve from human resources.employees. The columns that we want to retrieve are employee ID, employee first name, and employee last name. Line 16 shows the where keyword, which is used to specify the condition we want rows to meet in order to be included in the result set. Line 17 through 19 is the subquery. This subquery returns the employee ID for employees who place orders on or after May 1st of 2016 from the sales.order table. Therefore, lines 16 through 19 are the predicate for the query, which filters rows from human resources.employee by excluding the employees whose empl ID exists in the subquery set. Now I'll be hitting run, and as you guys can see, the results are here. The first table is from the original query of the T-SQL v4, and this is the result from the new query for the Northwinds database server. My second top query was exercise 3-1 from chapter 5. And this exercise asks me to write a query that calculates a real number for each order based on order ID, order date ordering. And the tables included were sales.orders. And this is the desired output. This is the code I wrote for exercise 3-1 for chapter 5. Lines 5 through 7 show the original query I wrote for the T-SQL v4 database. And after I got my desired output, I modified that code, and as a result, I got this new query to be run for the Northwinds database server. I'm going to hit run, and as you can see, I get my results. This table shows us the results from the original query, and this table shows us the results from the new query. Now, let's dive into the new query. So the code for the new query has the proposition, as I mentioned earlier, to calculate a row number for each order based on order ID and order date ordering. The tables in which data will be selected from is sales.order. Line 13 shows the select keyword, which essentially selects the columns to be retrieved from sales.order table. and we are retrieving the order ID, order date, customer ID, and employee ID columns from the sales order table. And in this case, the rows are ordered by order date and order ID, as we can see. That means that orders with the same date will be ordered by order ID. And then we have an as row num, which essentially renames the computed column to row num. Therefore, this order by, order date, and order ID can be considered as a predicate, since the ordering for assigning row numbers is based on order date and order ID. Exercise 3-1 was chosen as one of my top queries because it shows how we can generate row numbers by just using a specified order criteria, which is the order by, order date, and order ID. For my third top query, I chose a query from chapter 4 in which I had to write a proposition. This was the original code given to us, which can be found in chapter 4's subqueries file, and more specifically underneath multi-valued subqueries. And after some code modifications, I came up with this query that can be run in the Northwinds database server. And here are our results. And in order to come up with a proposition, I used my critical thinking skills and decided to break this query apart line by line. In the first line of code, we see that there is a select keyword that will be selecting the columns that we will be retrieving from this table, the sales.tables, from the sales.order table. Then I decided to look at this subquery, and this subquery will select the customer ID from the sales customer table where the customer country is equal to USA. Then I went back to line 12 where I see that the where clause will filter orders based on whether the customer ID is found in the subquery. Notice that this query will return orders placed by US customers. For top query, I chose a second query in which I had to write a proposition from chapter 4, which can also be found underneath the multi-valued subqueries section. In order to come up with a proposition, and decided to break this query line by line. The first line shows that it will select columns customer ID and customer company name from the sales customer table. So we have a where clause followed by a subquery. Query states that it will select customer ID from the sales order table, and it will find customers who have not placed any orders. To the where clause, and that's when I noticed that the where clause filters out customers based on whether their customer ID is not found in the subquery. Finally, after analyzing each line of code section by section, I realized that this query will return customers who placed no orders.
For my final top query, I decided to explain a proposition I created based on a query I selected from Chapter 5, Table Expressions.
In order to create a proposition for this code, I decided to break down the code into things I can notice first. I noticed that there was a subquery here and a subquery here, as well as a left outer join, and of course, the select keyword. First, I decided to understand the subqueries. What's the first subquery? And this subquery calculates the customers for each year by distincting the customer ID and grouping them by the year of the order date. Then we have a second subquery, which essentially does the same thing but for the previous year. And it does that by this line of code, which adds 1 to the year in the order year column and then grouping by the adjusted year. I realize that the main query performs a left outer join between cur and prev subqueries based on matching order year values. And finally, for the first 2 lines of code, these lines of code select the order year cur num of customers, prev num of customers, and calculates the growth as the difference between current number of cus and prev number of cus. After piecing all of these lines of code, I realized that the proposition for this code is to return the number of customers for the current year and the previous year, as well as returning the growth in the number of customers between both years.